Okay, so in this video we're going to look at how to find the nth root of a complex number. The first thing we're going to look at is in green at the top. And it says if z to the power of n is a plus b, then z equals a plus b to the power of 1 over n. So what I mean by that is, if I have a complex number and it's, for example, cubed, and that complex number cubed is 4 plus 3i, well then the complex number z is 4 plus 3i to the power of 1/3. Okay. Also, we know that in polar form a complex number is r cos theta plus I sin theta. In general polar form, instead of writing in just the two thetas, we add in a 2n pi. If you don't remember that, look at the video in complex numbers for general polar form. Okay. Right. So we're going to do this question, and we need to know this in order to be able to do this question. Right. It says solve z to the power 3 equals 8i. So what that means is there's a complex number, and when it's cubed, or there's complex numbers when it's cubed, it gets 8i. When they say solve, they mean we want to find the roots. So we want to find the roots of this. So complex numbers that are, when multiplied together, give me 8i. Right, that's what the roots are. Right. In this question, we should have 3 answers. Why? Because this is to the power of 3. If this was to the power of 4, we'd have 4 answers. If this was the power of 10, we'd have 10 answers. Okay? But we know we're going to have 3 answers. Or another way of saying it, 3 complex numbers that when multiplied together will give me back 8i. Okay. So what do we do? Well, the first thing we have to do, step 1, if this complex number isn't in polar form already, we need to put it in polar form. Is it in polar form? No. So we have to put it into polar form. And we know how to put a complex number in polar form. First thing is we sketch it out. So 0, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. So the complex number is here. 0 plus 8i. That's the complex number. Okay, I know it says 8i here, but I'm going to put in 0 plus 8i. There it is. What do I have to do? I have to find the radius from here to here. I have to find the angle theta here. Okay. Usually what we do to find the radius is and when I say radius, I mean modulus. So I'll be using radius and modulus interchangeably. If I want to find the radius of the modulus, I'll use this. Okay, so it'll be square root of 0 squared plus 8 squared, which is the square root of 64, which is 8. But to be honest, I could have read it straight from the diagram. Look, it's obvious that that's 8 because this complex, or this point here, is 8. Usually what we do then to find theta is we'd have to use the tan inverse of the opposite and the adjacent with a triangle here that we draw. However, there's going to be no triangle here because this complex number is on the y-axis. And if it's on the y-axis, we know that this here must be 90 degrees. And 90 degrees in radians is pi over 2. So radius is 8, and theta equals pi over 2. Okay. So we've put it into polar form. So here it is in polar form. 8 cos pi over 2 plus I sine pi over 2. we put it into polar form, so now I can say, instead of z to the power of 3 equals 8i, I can say z to the power of 3 equals 8 cos pi over 2 plus I sine pi over 2. With that in mind, then I can say z equals 8 cos pi over 2 plus I sine pi over 2 power of 1/3. Using de Moivre's theorem, then I can say z equals will be 8 to the power of 1/3 cos 1/3 pi over 2 plus I sine 1/3 pi over 2. Not finished yet though, because remember we have to have it in general polar form. So here, for this theta, instead of just leaving it as theta, we have to add in another 2n pi to here and here. So z equals 8 to the power of 3 cos 1/3 pi over 2 plus 2n pi plus I sine pi over 2 plus 2n pi. Right, and we just simplify this first. So we have z equals, and 8 to the power of a third is 2. And we have this as normal then. Cos 1/3 pi over 2 plus 2n pi plus I sine pi over 2 plus 2n pi. Okay, last thing we do. If you look back here, remember we said we're looking for 3 answers because this is cubed. If this here was to the power of 4, we'd be looking for 4 answers. If it was to the power of 10, we'd be looking for 10 answers. Okay, so how do I get those answers? Well, I will always start off by letting n equal 0. Always. No matter what power is here, I will always start off by letting n equal 0. And then I will let n equal 1, and then 2, and then 3, and then 4, all the way up to whatever number this is minus 1. Okay, so if that was 10, I would be letting n equal 0, and then 1, and then 2, and then 3, and then 4, and then 5, all the way up to 9. In my case here, it's 3. So I'm going to let n equal 0, I'm going to let n equal 1, and I'm going to let n equal 2. And that will give me 3 answers. One answer here, one answer here, and one answer here. Okay, so let's go. 2 cos 1/3 pi over 2 plus 2, and then we're going to let that equal 0 pi plus I sine 1/3 pi over 2 plus 2 0 pi. That will give me 2 cos 1/3. Now 2 multiplied by 0 multiplied by pi is just 0, so I'll actually be left with pi over 2 plus I sine pi over 2. Okay, we have 2 then Now, cos a third and pi over 2, you could throw that straight into the calculator, but I'm just going to keep going. So cos, now a third pi over 2 is actually pi over 6 plus I sine pi over 6. And that's 2. And cos pi over 6 then is root 3 over 2 plus, and I sine pi over 6 is I half. And we have to multiply it by the 2, so that would be root 3 plus 1I plus I. So there is one of my answers, or one of my roots. The next one, I put in 1 for n. So we'll start again, just give myself some more room. So we have 2 cos 1/3 pi over 2 plus 2, and then we put in 1 for n pi plus I sine a third pi over 2 plus 2, and again 1 for n, and working that out then we have there 2 cos 1/3, and then it's pi over 2 plus 2 1s are 2, and 2 by pi is 2 pi plus I sine, and it'll be the same over here, pi over 2 plus 2 pi. Okay, so that would be 2 cos 1/3, and pi over 2 plus 2 pi is actually 5 pi over 2 plus I sine, and the same again, 5 pi over 2, sorry, 1/3 5 pi over 2, so a third multiplied by 5 pi over 2 is 5 pi over 6 plus I sine 5 pi over 6. And then changing that into rectangular form using our calculator, we'll get, so cos 5 pi over 6 is minus root 3 over 2 plus I half, and multiplying that by 2 then we'll get minus root 3 plus 1I, or I. And there is my second answer. My last answer then, my last root, is I let n equal 2. So I start again. 2 cos 1/3 pi over 2 plus 2 pi plus I sine 1/3 pi over 2 plus 2, and I let n equals 2 pi, and I start working this out. So 2 cos 1/3 pi over 2 plus 2 2s are 4 pi plus I sine 1/3 pi over 2 plus 2 2s are 4 pi again. 2, and that's cos of 1/3, and that would be, I think it's 9 pi over 2 plus I sine 1/3, 9 pi over 2. So that'll be 2, and we have cos, and 1/3 of 9 pi over 2 is 9 pi over 6 plus I sine 9 pi over 6. Let's fix this up. No. We could simplify this 9 pi over 6, but there's no need. So if we type it into our calculators, then we get 2, and the cos of 9 pi over 6 is 0, plus I, and the sine of 9 pi over 6 is minus 1. So that will give us 2 zeros, or 0 minus 2i. So minus 2i is our third answer. So our three roots are root 3 plus I minus root 3 plus I minus 2i. So 8i has 3 cube roots as follows. And here they are. Just write it out again. Okay, and if you just want to check it, if you multiply all these together, you will actually get back to 8i. Okay, thanks.